Hello, my name is Dr. Dasari,
My name is Dr. Melody.
and today we're going to be talking about the world's biggest liar.
LeVar Ball.
No, atoms, because they make up everything. To understand how atoms work, we first have to go a little bit into their history, and it all started in 400 BC by a Greek philosopher by the name of Democritus. He proposed that the atom was the smallest unit of matter and was both solid and indivisible.
After Democritus, the next step in the atom's history was taken by John Dalton. He was a British chemist, and in 1807 he proposed how atoms work in matter through his 5 postulates. Number 1. Elements are made up of tiny indivisible particles called atoms. Number 2. Atoms of the same elements are identical. Number 3. Atoms of different elements vary in terms of size, weight, and matter. Number 4. Atoms of different elements combine in whole number ratios to form compounds. And number 5. Atoms of one element cannot be turned into atoms of another element through a chemical reaction.
Next up is a British chemist by the name of J.J. Thomson. Don't worry, he wasn't related to Clay Thompson.
Or his Blue 3-1 lead.
But in 1903, he discovered the first negatively charged subatomic particle, the electron. And with this, he managed to create something known as the plum pudding model, in which there was a sphere of a positive charged area in which small little negatively charged particles, electrons, would drift around it. Think of it like a chocolate chip cookie. In a chocolate chip cookie, the dough would represent the positive charged area, and the chocolate chips would represent these small little negatively charged electrons floating around within this sphere. And how he did this was quite simple. He used something known as the cathode ray experiment, and it involved gases discharging electrical light energy particles, making them excited. And effectively what happened was these particles moved toward the positive end of the magnetic field, which meant that these particles were negative, allowing him to discover the electron.
Hey Sarge, what's up with all these British chemists doing everything? Where are the Americans at?
Bro, look at your notes. We're about to go to RAM.
The computer?
No.
Oh wait, okay then. For all those of you who are wondering, RAM is not the computer like I thought. It actually is the initials for Robert A. Milken, the next scientist we're going to talk about. He was an American physicist, and in 1909 he discovered the specific numeric values for the charge and mass of an electron. He did this through his oil drop experiment. Essentially, he allowed oil to drop in a container that had both positive and negatively charged plates. Through multiple trials, he realized that there was a charge to mass ratio. By using that ratio, he discovered that all charges of an electron were multiples of 1.60 times 10 to the power of negative 19, and that the mass of a single electron is 9.11 times 10 to the power of negative 28 grams.
Next up is Ernest Rutherford. And in 1911, what he did was he made a new model for how the atom should exist. What he found was that the atom has a densely positively charged nucleus, a bunch of negatively charged electrons, and the rest was mostly empty space. He did this by doing something known as the gold foil experiment. He shot alpha particles at a piece of gold foil and noted that though some of them actually just went through without anything happening to them, some of them bounced off. And that led him to having 3 conclusions. First, that the atom had a densely charged nucleus and a center. Second, that mostly an atom was negative empty space. And third, that the middle of the atom, the nucleus, was positively charged.
After Rutherford, there came a famous scientist by the name of Niels Bohr. He was actually a student of Rutherford, and in 1913 he proposed his own model of what the atom looked like, the Bohr model. His model composed of the negatively charged electrons orbiting around in specific circular paths, known as energy levels or energy rings, that orbited around a positively charged nucleus. In his model, the lower the energy level meant lower energy, which also meant the closer it is to the nucleus. Furthermore, his model stated that electrons cannot exist between energy levels. This led to the idea of quantum, which is the concept that there's a certain amount of energy required for one electron to jump from one level to another.
Now, what do the Cardinals and Ernest Rutherford have in common? They both had an amazing comeback. And Rutherford had his amazing comeback in 1918 when he came back and discovered the proton, furthering his own ability within his atomic theory. He also found out that the atom was too unstable to only have a proton in it without something else being there.
This led to James Chadwick's discovery in 1932 of the neutron. He discovered that the neutron had the same mass as a proton, but had no charge. It was neutral. This explained Rutherford's problem of the atom being too unstable to just have protons in the nucleus. This also led to the proposal of a new model that was similar to Bohr's model, but included neutrons with protons in the nucleus of the atom.
Together, these scientists helped establish the modern atomic model.
This modern atomic model contains neutrons, protons, and electrons.
Inside the nucleus are the protons and the neutrons, and outside, on the electron rings, are the electrons.
Each atom has a unique number of protons that stays consistent through different versions or isotopes of the atom. You can think of the number of protons as a unique name tag for each atom. The nucleus also contains neutrons, which have a charge of 0.
On the electron rings lies the negatively charged electron. Usually in an atom, there's the same amount of electrons and protons, resulting in a charge of 0.
However, some atoms can have different number of electrons or neutrons. In this specific case, we'll be talking about different numbers of electrons. Some atoms tend to gain or lose electrons to achieve the noble gas or octet state. This means that if an atom loses electrons, it becomes a cation and is usually a metal. If an atom gains electrons, it becomes an anion and is usually a non-metal.
However, in other cases, the atom can have a different number of neutrons. This situation is called isotopes. And isotopes don't follow a normal formation period. Light atoms have the same number of protons and neutrons, whereas heavy elements have more neutrons than protons. But sometimes atoms can have a different number of protons and neutrons, which can cause them to be stable for a little while, but eventually they won't be stable.
Now we'll be talking about electron configuration. In order to know your electron configuration, you must know the location of your S, D, P, and F block. The location of the S block is in groups 1 to 2, the D block is in groups 3 to 12, the P block is in groups 13 through 18, and the F block is the intertransition metals at the very bottom of the periodic table. The S block starts in groups 1 to 2 and goes down the period into 6s2. The D block starts in groups 3 and goes down the period to 6d10. The P block starts in group 13 and goes down the period into 6p6, and the F block starts in the intertransition metals and goes down to 5p14.
The electron configuration for luteum is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, and 5d1.
Hello, my name is Lakshman Ball, and I'm the 5th Ball brother, owner of the Big Biology brand. Today I'm going to be talking a little bit about the electromagnetic spectrum. The electromagnetic spectrum is the entire range and scope spectrum of frequencies and the respective wavelengths of the electromagnetic radiation and photon energy. Light is a form of electromagnetic radiation. Now, when electrons get excited, they jump to higher energy levels and tend to fall back down. Depending on how high they jump, they give off different colors of light. The light energy is quantized, meaning a specific amount has to be absorbed and all of it ends up being released. Only certain amounts are allowed. The atomic emission spectra is visible when atoms go from a ground state to an excited state by gaining energy, and an excited state to a ground state by losing a photon. Every element has a unique emission spectra. The colors that you see represent the element's electrons jumping through energy levels. Now, long jumps are represented by high energy colors such as violet or blue, while shorter jumps are represented by lower energy colors such as red. Now, red is typically 700 nanometers long, whereas violet, which represents most energy, is about 400 nanometers. And before the 1900s, scientists thought that light behaved solely as a wave. This belief changed when it was later discovered that light also has particle-like characteristics, making light one of the most interesting concepts in our entire universe. This is called the wave-particle duality of light. The significant feature of wave motion is its repetitive nature, which can be characterized by the measurable properties of wavelength and frequencies. Wavelength is the length of one complete wave, which is usually measured in meters, but can also be measured in centimeters and millimeters. And frequency is defined as the number of waves that pass through a given point in a period of time, usually a second. Electromagnetic radiation is the form of energy that exhibits wave-like behavior as it travels through space. Together, all forms of electromagnetic radiation form the electromagnetic spectrum. On the electromagnetic spectrum, the lowest energy waves, longest wavelength, and lowest frequency are waves. And the highest energy waves are gamma waves. Frequency and wavelength are inversely proportional in general, while energy and frequency are directly proportional as a whole.
Gucci gang, 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 Gucci gang.